Today we're going to learn about the three types of solutions that cells can be in. Two of them cause the cell to lyse or die. One of them will cause just the cells to remain normal. You'll also begin to think about why your fingers get shrivelly when you're in the bathtub. Let's take a look at them. Types of osmosis. Remember, osmosis is the diffusion of water across a membrane. Some key solutions can be from this. Remember, osmosis is the diffusion of water across a membrane. Depending on the flow of water, though, we can determine the solution that a cell is placed in. What are the types of solutions cells can be in? Hypertonic, when there is more concentration of water in the cell than without. Because there is more water in the cell than without, due to the laws of diffusion, the water will want to move from a high concentration to a low concentration. In other words, out of the cell. Water will move out of the cell, causing it to shrivel. Cells placed in a hypertonic solution, because the water is leaving, end up looking shriveled and almost like raisins. This is because all the water is leaving them, causing support and structure to go away. Here's an example of red blood cells placed in a hypertonic solution. Notice, as the solution flows over them, they begin to shrivel. This is because, once again, there is a greater concentration of water in the cell than outside. The water is leaving the cell, causing it to shrivel up. Hypotonic, when there is a greater concentration of water outside the cell than inside. In a hypotonic solution, there is more water outside the cell than inside. Because of the laws of diffusion, water will want to move into the cell, causing it to swell. Water moves into the cell, causing the cell to swell up and eventually burst. In a hypotonic solution, because water is moving into the cell, it will cause it to swell up and almost look like a sphere. This will continue until the cell bursts. Here's an example of some blood cells in a hypotonic solution. This is kind of difficult to see, but notice how the discs in the center of the red blood cells begin to lose their shape. This is because pure water is being passed over them. Because there's a greater concentration of water outside the cell than inside, water moves in, causes the cell to swell, and eventually burst. Water moves in and out of the cell at an equal rate, keeping the cell the same. Because in isotonic solutions, the amount of water is equal inside and outside the cell, the flow of water into and out of the cell is the same. Isotonic, the amount of water inside the cell and outside the cell is equal. This causes cells to keep their shape. As you can see in this video, what's happening is that the cells are keeping their shape because they're pumped with an ideal solution. Water is flowing in and out of the cell, but it's at a constant rate, so the cell doesn't change its shape that much. Now you know the three types of solutions. Remember, hypertonic, water flows out, causing the cell to shrivel. Isotonic, water flows in and out at an equal rate, causing the cell to stay the same. And hypotonic, water flows into the cell, causing it to swell and burst. A way I like to remember it is an idea of this. Hypotonic sounds like hippo, and hippos are big, causing them to swell. Another way you can think about it is hypers, typically you're burnt out after you're hyper, or shriveled up. That's the way to think about it. My question to you, and I'll answer this on Thursday, is the idea of this. Well, when you get in the bathtub, why is it that your cells get all shrivelly, or it appears to look all shrivelly on your hand? Is the bathtub a hypertonic, hypotonic, or isotonic solution? Talk to you guys later. Have a good one.